Hello dear friends, a very warm welcome to the today's session. In the today's session we will learn how to control the speed of DC series motor by a armature resistance control method. Before going to the practical aspects, let understand already we have studied we have discussed this in the theoretical part lecture. We will just glance on that. So the speed of a DC motor is Q1 by N is directly proportional to EB by phi. In this expression, N is speed of the motor, EB is the back EMF, and phi is a flux. So EB already what it is already you know. EB how it comes. So what is the EB? I will just glance. EB is nothing but a back EMF. How it produced? So we want to run the motor by giving a supply to the motor, but what happens when it is rotating? When rotor rotating, while rotating it cuts the flux and EMF will be induced in the rotor, and the direction of that rotor and supply is in the opposite direction, and we call it as a back EMF. Okay, and it is EB is equal to what? V minus IARA in case of a DC motor. Okay, so now N is K V minus IAR divided by phi. So from this expression we can say that speed of the motor can be varied by first by varying the flux, that is known as flux control method. Already we have done on this. By varying a flux we can control the speed, and already we have done in the previous experiment, that is experiment number 2. If you want to if you missed that, you can see my second lecture of DC motor experiments. Okay. By varying a resistance in the circuit we can control the speed, and that method is known as armature resistance control method. And another one method is there. By varying a voltage we can vary the speed of the motor, and we call it as a voltage control method. In this experiment in this session we will see how to control the speed of series motor by varying the armature resistance. So what happens? We have connected the variable resistor in series with the supply voltage, that is a V. You can see here supply voltage and across the armature. So what we are exactly here doing is we have connected between the supply and armature, and here we are reducing the supply to the armature. As supply increases, current through armature will increase. So as supply will increase, the speed of a EB will be increased. So as across this one, whatever the voltage, if it increases, then speed of this one will be increase. We know already the expression. N is directly proportional to EB by phi. EB is nothing but V minus IARA. So as you increase the supply across the armature, then speed will increases. This is very simple thing. As you vary, when the resistance is high, the drop is high, hence there is no movement in the motor. As you decrease the resistance, then the motor will rotate, and when the resistance is 0 you will get your maximum voltage. In this experiment, so you can control the speed of the motor below the rated. So this is the drawback of this system, because you have connected, you are inducing the drop. So what happens, if you make a resistance as 0, it will run to the, you can run to the rated speed. If you increase the resistance, what will happen, the speed will decrease. There is no any in this experiment, there is no any such arrangement that we can increase the speed above